introduction to power quality, and we will talk about the harmonics and some power quality problems like the voltage sag, voltage swell, voltage fluctuation, voltage imbalance, transient. Okay, so these are some of the power quality problems, and we will go on a short introduction on the ETAP and how we are going to do the harmonic analysis in the ETAP. Okay, so hands-on we will do that, and then we will design some harmonic filters in ETAP. Okay, so what is harmonic filters and how to design in ETAP, that we will see at the last. Okay, so this is the short agenda of our webinar. So moving on to our session. So the first question which comes to our mind is, what is power quality? Okay, so what is power quality is, the IEEE has defined power quality as the ability of the system or equipment, okay, to function satisfactorily in its environment without any electromagnetic disturbances. Okay, so it is tolerable to any of the electromagnetic disturbances, means it is a qualified power system. Okay, so the power quality mainly depends on two things: the continuity of the supply and the quality of the voltage. Okay, so there are two things to be considered while we are speaking about the power quality. So collectively, we can say a perfect power system is one which is always available and have the voltage and frequency within the tolerances and has a pure noise-free sinusoidal wave shape. Okay, so these are all the characteristics of a perfect power supply. Okay, and then moving on to the next slide. So what are all the power quality issues? So if any issue which causes the voltage, current or frequency of the nominal wave to be changed, okay, so that we will be termed as like power quality issues. There are various power quality issues in our power system. Okay, so these are some of the types of power quality issues like harmonics, voltage fluctuations, and voltage unbalance. Okay, and power quality, power frequency variations, and transient. Okay, so these are some of the common power quality issues we face in the power system. Okay, and DC in AC network, it is not applicable here. Okay, and the magnetic and electric field disturbances, and electrostatic discharge is also one of the disturbance. Electromagnetic discharge is also one of the disturbance. Like this, many types of power quality issues are in our power system. Okay, so we will go in detail about these power quality issues. First, we talk about the harmonics. So what is harmonics means? Like any deviation from a perfect sine wave can be represented by the harmonics. Okay, and then we can describe the harmonics as a multiple sinusoidal component having the frequency that is the integral multiple of the fundamental frequency, that we call as the harmonics. Okay, so you can see here in this picture, like many frequency of waveforms are presented here. Okay, so all these together forms the harmonic waveform. Okay, so this is the resultant waveform that forms the resultant waveform, that is the harmonic waveform. Okay, so collectively we can say like the waveform corresponds to the sum of the different sine waves with different magnitude and phase, and having frequencies that are all the multiples of the power system frequency. Okay, so that is the harmonics. And then speaking about the causes of the harmonics, what causes the harmonics? Okay, so there are many causes for the harmonics like arc furnaces, welding machines, rectifiers and all. Some of the causes of the harmonics in generally we can term as all non-linear loads. Okay, all non-linear loads causes the harmonics to be introduced. Okay, so then moving on to the next type, that is voltage sag. Okay, so the voltage sag is nothing but there will be a decrease in the voltage. Okay, so there will be some decrease in the voltage for a small period of time, so that we term as the voltage sag. That is the reduction in the AC voltage at the power frequency for a duration of like for less than 1 minute. Okay, for half cycle or up to few seconds, there will be some reduction in the voltage. So that we term as the voltage sag. Okay, so the voltage sag is characterized by mainly by two parameters, one by the magnitude and the other by the duration. Okay, so magnitudes should be between like 10 to 90% of the nominal RMS voltage, and the duration has to be between 0 to sorry the 0.5 cycles to 1 minute. Okay, so this is called voltage sag, and the causes for the voltage sag may be like any faults in the transmission or distribution network, and any faults in the consumer installation and all causes the voltage sag. Okay, and the transformer energization like that and all will causes the voltage sag. And the consequences of the voltage sag is like tripping of the relays or okay, so disconnection and loss of efficiency in the electric rotating machines and all occur due to this voltage sag. And then talking about the voltage swell, this is just the opposite of the voltage sag. Okay, so voltage dip, it is opposite of the voltage dip. Okay, so that is called the voltage swell. The in the voltage swell, what will happen means there is a momentary increase of the voltage. Okay, there is a decrease, here is the increase of the voltage. This also may be uh, it is characterized by the voltage, the magnitude of the voltage and the time duration. Okay, so what are the causes for this voltage swell means like start and stop of heavy loads and badly dimensional power sources and all will causes the voltage swell. Okay, so these are all the causes of the voltage swell, and the consequences of the voltage swell is like flickering of the lights. Okay, and damage to any sensitive equipments and all will occur while during the voltage swell. Okay, and then speaking about the voltage fluctuation. So what is voltage fluctuation? You can see it from this graph itself. Okay, so from this graph itself you can infer what is the voltage fluctuation. So it can be described as like it is oscillation of the voltage value. Okay, so it is the oscillation of the voltage value, or we can term it as the repetitive or random variations of the voltage. Okay, so repetitive or random variations of the voltage envelope modulated at a minimum frequency, like lesser frequency, like 25 hertz. Within 25 hertz frequency, it is uh, repetitively changing. Okay, so for a human eye, it can be detected as a variation in the lamp intensity due to the sudden change in the real and reactive power consumed by the load. Okay, so that is called as voltage fluctuation. So the causes for the voltage fluctuation are like the arc furnaces, okay, and the frequent start and stop of the electric motors, oscillating loads and all causes this voltage fluctuation. Okay, so this is about the voltage fluctuation. Then moving on to the next slide, the voltage unbalance. So we know that in balanced system, the three line to neutral voltages are equal in magnitude and are phase displayed from each other by 120 degree. Okay, so this is the normal condition. If any deviation occurs from the normal condition, okay, so if any deviation occurs from that normal condition means we term it as the voltage unbalance. Okay, uh, the causes for this voltage unbalance are like large single phase loads. Okay, so if we connect any large single phase loads on one particular phase means there will be some voltage unbalance occur. Okay, and this causes the negative sequence current to flow in the three phase loads, and this is harmful to our loads. Okay, so this basically occurred when the induction loads are connected. Okay, so this causes overheating, like noisy operation of the loads and all may be occur due to this voltage unbalance. Okay, then moving on to the next slide, this is the power frequency variation. So the nominal power frequency here in India and all, there is a 50 hertz frequency we use. But in other countries like USA and all, they use 60 hertz frequency. Okay. So if any deviation from that frequency, like if it is reduced or increased above this nominal frequency, means that we termed as the power frequency variation. So this is caused due to some poor speed regulation alternator. Okay. So these are all the causes of the power frequency variation. Okay, so this is a simple thing only. And then moving on to transients. So what is transient means? Like if it is caused by the injection of the energy by some switching devices. Okay, so by switching devices, there will be some injection of the energy. Okay, so the amplitude of the voltage waveform suddenly increases to a very large value. It will be increased to a very large value, and then it will be decreasing to a nominal value. Okay, so that sudden increase we term it as transients. Okay, so this may be caused due to some removal of the heavy load, fault in the network, and operation of the circuit breakers and all will cause the transients. Okay, so these are some of the power quality issues we face in our power system. Okay, so any doubts up to this?